All right, so this video is about simplifying radicals. And the first question says, simplify the radical, the square root of 18. So simplify the square root of 18. This symbol here is a radical. This type of radical is called square root. Square root. The square root is basically this symbol, and it looks like a division symbol with a little kickstand next to it. So that means square root. So it says the square root of 18. So to find the square root of 18, basically what you want to do is this. You want to break apart 18 to be any number that you can go and know that goes into 18. So you think of a number that goes into 18, you might think, well, 2 and 9 is 18. So 2 times 9 is 18, which is true. So you can break 18 apart to be 2 times 9. And then from there, what you're looking for are perfect squares. Like 9 is a perfect square. So technically, I can square root the 9. So technically, you could say this. You could call this square root of 2 times the square root of 9. Because each one is being square rooted. Square root of 9 is 3. So this becomes the square root of 2 times 3. So final answer is 3 square root of 2. And it's really nice if you know the perfect squares. Like 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. The next perfect square is 25. The next one is 36. Next one is 49, and so forth. So if you know all the perfect squares, like from 1 to 25, it's useful because you save some work. Like you'll save the fact that you just know that the square root of 9 is 3, and you can easily find the answer. Now, if you don't know the perfect squares, you have to do it a different way. If you didn't actually know that, I'm going to erase this. I'm going to look at that same problem, and I'm going to answer it as if I didn't know the perfect squares. So if you don't know the perfect squares, if I took that problem, square root of 18, and I didn't know the perfect squares, you might have thought, well, 3 can go in 18. So 3 times 6 is 18. All right, so you might look for any number that's a perfect square, but since you don't know it, your goal is to break it down to all prime numbers. If you don't know the perfect squares, the best way to get the right answer is to break it down to all prime numbers. So 3 is prime. No number can go into 3 but 1 in itself. 6 isn't prime. It's composite. It has factors. So we want to break that apart. 3 is prime, so it comes alone. The 6 can be broken apart to be 2 times 3. Great. So once we get here, we're going to look to see if it's all prime or not yet. And we notice 3 is prime, 2 is prime, 3 is prime. So all those numbers are only divisible by 1 in itself. So all those numbers are prime. So since they're all prime, once you get to this point where they all are prime, what you're looking for are all the numbers that are identical. You look for pairs. So this pair, 3 and 3, that pair comes to be one of the numbers outside. So that pair, this 3 and the other 3, comes together to be 1, 3 on the outside. Underneath the radical, the only number that's left is a 2. So underneath the radical, the only number that's left should be 2. So we'll get the answer, should be 3 square root of 2. Same answer we got here, this you added a step though, but you'll still get the right answer. So if you don't know the perfect squares, and you don't know what the perfect squares go into a number, I suggest you break the number down to be all prime numbers, and then look for all the pairs. And each pair comes outside one at a time. Now, when you're doing this, do not do that stuff that you might have learned in some grade called the factor tree. Do not do that in doing these problems. That is no use here because it's very confusing of what goes where. So don't do that ever. A lot of people don't remember how to use it anyway. So don't bother using the factor tree. Do write the answers, the factors out horizontally as I did here. All right, I'm going to give you a new example. I'm about to erase the screen, so if you want any of that, I'll write it down. So this example says, simplify 2 times the square root of 18. Let's rewrite it here. 2 and the square root of 18. So since the 2 has been multiplied by it, I'm going to leave it outside. And whatever comes outside with it is also going to be multiplied to it. So let's break down 18 again. We decided 18 was really 3 times 6. And then we decided that that was really 3 times 6 times 3. And what we decided was these two 3's can be 1 3 outside. So outside there's already a 2, and now there's a 3, and there's just a 6 left. Oh, I'm sorry. That 6 should be a 2. Sorry about that. That 6 should be a 2. So it should be 2 times 3 times square root of 2. Well, that's 6 square root of 2. Called 2 times 2 is 6. So it means 2 times the square root of 18 is really 6 square root 2. All right, you can copy that as a note. I'm about to erase the screen and give another one. All right, directions here is simplify the square root of 75. So we'll take the square root of 75. I'm going to think of all the numbers that can go into 75. You can pause the video and try it on your own if you want, and then join me and see if you got it right. So pause the video now and see if you can figure this out without my help. All right, so if you pause the video, you might have thought, well, 5 can go into 75, because 5 goes in any number that ends in the number 5. So since 75 ends in number 5, I know 5 can go into it. 5 goes into 75 15 times. All right, so 5 is prime, 15 isn't prime, so I can break it apart. So this becomes 5 times 5 times 3. And then all these numbers are prime. 5 is prime, 5 is prime, 3 is prime. So from there, both of these 5s are identical pairs. So these two 5s become one of the 5s outside. So the answer is 5 square root of 3. So the square root of 75 is equal to 5 square root of 3. All right, write that as a note if you didn't get it. And if you did get it, let's go to the next one. This new one says, simplify the square root of 72. So looking at that, I got the square root of 72. 72. Truthfully, try it on your own first. Pause the video, try it on your own. Then join me if you think you got it right. Let's see if you got the right answer. So pause the video now, try it yourself. All right, so we paused it and tried it. I would think, okay, 72 is even, so I know 2 can go into it. So I could say this is really 2 times 36. And truthfully, you recognize 36 is a perfect square. You could square root it and be finished. But if you didn't recognize that, you'll probably think, okay, 36 is even. I could divide that by 2. So I can call 36 2 times 18. All right? And you can think, well, 18 is even. So I can divide that by 2. That's going to be 2 times 9. And then all these are prime except the 9. So I got to break apart the 9. So that's going to be 2 times 2. And the third 2 comes down. And the only number that changes is a 9. The 9 becomes 3 times 3. So now that everything is prime, 2 is prime, the 3's are prime. Now that everything is prime, we can find all the numbers, that all the pairs are identical. So these two 2's are identical. Oh, let me write a new example, just in case I need more space. So I'm going to put it up here. With the same numbers, I'm just going to rewrite it. 2 times 2 times 2 times 3 times 3. So again, these two 2's are one pair of identical numbers. So they come outside. These two 3's are a second pair of identical numbers. So it comes outside, being multiplied to the 2. The only number underneath the square root symbol that's left is this 1, 2 here. It has no matches, so it stays. So since 2 times 3 we can multiply, I can call that 6 square root of 2. And that would be the final answer. So with that being said, that's all I have. I'm going to give you 4 or 5 examples to try on your own. So try these before you come into class tomorrow. So write down these 3 examples, try them on your own, and good luck. We'll talk about it when you enter tomorrow. That's all I have. Good luck.